This video introduces a system of equations and explains how to solve a system of equations graphically. Let's get started. First of all, a system of equations is where you have two or more equations that are describing the same situation, meaning that the x value and the y values, for example, in all the equations are all happening simultaneously. Okay. Now, when we solve these graphically, we're looking at two different graphs. So, for example, this circle graph right here, as we learned in geometry, can be described by the equation x minus 0 squared plus y minus 0 squared, because 0, 0 is the center of the circle, is equal to the radius of 4 squared. Okay? Now, what that means is that every single point on this circle, at every point on the circle, will make this equation true. Okay? So, all these points on the circle, every single point on the circle, makes that red equation true. Now, this line, as you learned in Algebra 1, can be described by the equation y is equal to, the slope is -1, so negative x, and the y-intercept is 4. So every point on this green line can be described by this equation. Okay. Now, the idea of a system of equations, these two equations, the red one and the green one, when are they both true at the same time? Well, they're true at the same time when there's a point that is on both of the graphs. So this point right here is a point that's true in both equations, and that point is the point 0, 4. To show that to you, it looks like this. So in both equations, I get a true statement, and so that is one of my solutions. The other one is right here at the point 4, 0. And again, I can plug in x is 4 and y is 0 and get a true statement both times. It looks like this. And you get a true statement both times. So basically, we're looking for the intersection points on the two graphs. Okay, so for this one, this intersection point is the point -3, 0, and the point 0, 3. Okay, which I know seems super simple, but you have to understand that every point on both of the graphs make those corresponding equations true, and so I can solve the system at where those two graphs intersect. Okay, here is another, besides a circle and a line, here is a parabola and a line. Again, I'm looking for the points that make both equations true, which is this one, which looks like the point -3, 9, and this point over here, which is 1, 1. Okay, and I could write the equations for both of these and plug the points in, but the point I want you to get right now is that these 2 points where they intersect are the points that make both equations true at the same time. All right, this video introduced systems of equations and also how to solve them graphically and what that means to solve them graphically. Thank you so much for watching.